Welcome everyone to another learning session. Tell me one thing. How many of you have played this Lego game? We also have movies based on the Lego building blocks, right? Systems design fundamentals are also like that. To actually build systems, we need a lot of building blocks. Whatever we are learning now are all building blocks that are needed to build good and efficient systems. In part 1, we learned about some very important core concepts. And part 2, we learned some very important characteristics. And part 3, we were supposed to learn about some concepts that can help these characteristics. And in part 4, we were planning to learn some components. But while I was going through these materials, I felt like these concepts and components, they are very difficult to separate. So now part 3, I have made it as concepts and components that can help characteristics. And part 4 will be existing systems, like the S3 bucket or Kafka queue, something of that kind. Systems Design Fundamentals 101 part 3a. And in this part 3a, we will be looking into concepts such as caching, hashing, load balances, and even proxies. And just in case if you are new to these sessions, I am Hartin Gangathotu. I have written few books and have some Azure certifications. And if you want to know anything about me, you can look into hartin.github.io. I have actually combined part 3 and part 4 and created a new part 4. Part 3, concepts and components that influence characteristics. So in this session, we will try to look into things such as caching, load balancers, hashing, and proxy. Caching. Caching is a process of storing extra copy of data so that we can access them faster. Caching is generally used to improve latency by storing data near to its usage. Common caching use cases. We can use caching to store the results of a computation-intensive operation. For example, we are doing some kind of computation, and this computation is a very costlier operation. We do the computation once and store the result, and whenever somebody asks for that result, we will actually return back. Whenever you are making any network request, it will take some time, right? We learned about latency and throughput in a previous session, right? To avoid that extra network request, there also you can cache data. So whenever you are making a call to your database or from another system, you get the results and you cache it, so that next time when you need it, you don't have to make that database request, or you don't have to go to the other system through APIs. So to reduce the load also, you can have a caching at various different levels. So these are just some of the common caching use cases. And also, can you tell me some of the common tools or databases that are used for caches? Redis, which is actually a key value pair database. So quickly, give few examples of places where we can cache data to improve latency. So imagine a situation where I have a client is making a request to a server, and server is connecting to a database. So tell me, where all I can cache? You can cache data at the client side, or servers can also cache data to avoid going to database every time. Caching can happen not only at the software side, it can even happen at the hardware level. If you look into the specification of various chipset these days, you can find, you know about content delivery network when we learned about cloud, right? So whenever we have the source and destination in different parts of the globe, content delivery networks can really help speed up Basically, they are caches in various different locations. So instead of always going to the source, you need to only go to that caches which are sitting nearby to you. Okay, so you can have a caching at various different levels. Sudeep is mentioning about CPU cache. Lakshmi is mentioning about ETL tools use caching concept while performing the data transformation. So give examples for caching at the client, server, CDN, and hardware levels with respect to our reference example, a client connecting to server and server connecting to a database. You can give examples for various different tools that can be used in each of these places. As I told you in a previous session, whenever you are searching for these things in Google, you are not going to learn only the answers for these. You'll be seeing a lot of things, lot of related things. All these related things can definitely increase your breadth of knowledge. And unless you are doing some kind of exercise after these sessions, there is really no use of attending these sessions because you are going to forget all these very soon. Okay, I have a cache and I have a backing store. Imagine it is a database. So for reading, we saw it is easy. But for writing, there are two options, right? Cache is now sitting in between my source or the backing store or the database and wherever I am accessing it. Let us call it as a client. So whenever I am reading something, if that thing is not there in the cache, it will take it from the database and then it will keep it in the cache. But what about writing? While writing, then also this cache is sitting in middle, right? So there are two options. One, write to cache and immediately write to the backing store. And second option is write to the cache, but do not immediately write to the backing store. Maybe when we have more data, then write it or write it asynchronously. So which of these is better for performance? So write back cache is more performant because we are not always going to a database. Okay, we are writing to the cache and immediately returning back and then going to do our other operations. Which of these is more consistent when we work with a large distributed environment? Write through cache, right? The life of a software architect is all about trade-offs. So you have to understand which one will work for your particular use case, and then you have to choose that one. Quick question. How do you manage stale data in a cache? What do you mean by stale data? I am going to the cache and cache is not having a value for a data, and this cache will get the data from database, and from then I am only looking into the cache. So what if the data changes in the backend, or what if the cache becomes full? What will you do? Stale data means data has changed in the backend, but still we are using the old data. Dealing with the mutable data in distributed systems are little tricky as it can lead to stale data very fast. And if you are dealing with immutable data, or if staleness and consistency is not a problem, caching is much easier to implement. What do you mean by immutable data and mutable data? Immutable data means data that doesn't change or you cannot change it. Mutable data means data that can change. So if it is immutable data, then you don't have to worry, right? Nobody is going to change it. And if it is the result of a computation, in general, it also do not change, right? As long as A and B are not changing, their product will be always same. And even if it is immutable data, sometimes your cache can become full, right? So when the cache is full, we have to also remove some of the entries, and that is called as eviction. And there are many policies for eviction. One common one is least recently used. We can remove least recently used ones from the cache, or maybe least frequently used, or maybe first in, first out. Quick assignment for you to work. List down some real world use cases of caching. Specify an efficient eviction strategy for these use cases. As I mentioned, my goal is to provide you with things that you can use to start discussing within our group. So then only it will be a study group. Otherwise, it will be just a course or one-man show, right? And for all those people who are learning programming or already doing programming, then you can do this assignment. This is a very common interview question also. If you are on the programming side, demonstrate LRU caching using any programming language of your choice. And if you know about things such as linked list, hashing, all those concepts we have learned in our programming sessions, right? Those things, those data structures and algorithms and knowledge you can use, and then you can complete this LRU caching problem. If you are watching it later in YouTube channel, you can share there, participate, then only you will learn. Hashing. As per definition, a hash function is any function that can be used to map data of arbitrary size to fixed size values. And also, these hash functions has a very important property. For a given input, a hash function will always return the same output. However, multiple inputs can have the same output. And how do you say that a hash function is good or bad? So a hash function that returns the same output for all the input is still a valid hash function, but it is not a good hash function. A good hash function will equally distribute its inputs. Okay, I'll give a small example. Imagine that I have 100 students in my class. And if I want to search for one of those students, what is the worst number of comparisons I will have to make? It is 100, right? So what if I divide them into different groups? Okay, what if I divide them into groups of 10 students? And whenever I give input as name to my hash function, it will tell me which of these 10 groups that student belongs to. And in that case, I'll have to look for only 10 now. And the best hash function is one that makes sure all of these groups will have only one student. So that with only one comparison, I'll get the result. So I'll go to the hash function, I'll get the group, and with only one comparison, I'll get the result. So this is the best case. But in a real world, it may not be the best. And when you look into hashing from a data structures and algorithms perspective, you call these groups as buckets. And generally, you can implement these buckets using, or the first level of buckets using arrays. And then when two different inputs give the same array index location, it is called as a collision. And then generally you can use data structures such as linked lists or trees to add more elements to a single array location. And how do you convert a given input into one of these fixed locations? Say my array has locations with indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And somehow I converted my input into a number. And this number has to be put into one of these 10 buckets or 10 locations, which has an index value starting from 0 to 10. How can I convert any given number into one of these 10 locations? I can use a mathematical function. Can somebody tell me the name of that mathematical function that will help me convert any given number into a number between 0 and 9? Okay, it is a mod operator, or you can call it as a remainder operator. To make things simple, if you have 4 locations, 0, 1, 2, 3, and then you want to convert all numbers to any number between 0 and 3, both included, then you can use mod operator with the number 4. So what is 0 mod 4? It is 0. What is 1 mod 4? It is 1. What is 2 mod 4? It is 2. What is 3 mod 4? It is 3. And what is 4 mod 4? It is 0. What is 5 mod 4? It is 1. What is 6 mod 4? It is 2. Basically, you will do the division and take the remainder. And hashing is used for achieving many characteristics such as availability by helping in routing for load balancers, and caching can help in performance. We saw some examples, right? We can use data structures such as hash tables for faster access of data, and you can use hashing even in security, especially for storing passwords. Quick question: which is more secure for storing passwords, hashing or encryption? We have already learned encryption in very good detail in session 1. This is a very important question even for interviews. If you're watching this recording, just pause and think and answer. 99% of the people here have told encryption. So the answer is hashing. So in almost all databases, they store passwords as hashes, because hashing is a one-way process, unlike encryption, which is a two-way process. With encryption, you can convert plain text into ciphertext, and with the decryption, you can convert that ciphertext back to plain text. With hashing, you convert your password into a hash and then store that hash in database. Imagine that we have two databases. One uses hashing mechanism and one uses encryption mechanism. In the hashing based database, whenever a user enters a password for the first time, a hash is created and stored in database. When the next time, whenever the user enters the password, system will generate the hash and then compare the hashes. It will compare the hash that is stored in database and see if the hashes are matching, then you are allowed to go inside. There are additions to it. I'm trying to make it very simple here. In encryption, whenever you are entering your password, system will decrypt whatever is stored in the database and it will compare. What if somebody hacks into your database? The database with encryption, they can decrypt. You always have the possibility of getting back the original data from encrypted data. That is the whole point of encryption and decryption, right? If you encrypt the data, then you can decrypt the data. But in hashing is a one-way process. You can never get your original input from the hash. So if a hacker gets access to the database, he will only get the hashes, but he will never get the actual data. So that is the primary difference between using hashing for storing passwords versus using encryption for storing passwords. As a assignment for my coding friends, implement a hash table using any programming language of choice. I've given clues, right? You can use an array, and then you can use a linked list or tree for handling collisions. And some of the logic I have also mentioned in my data structures video that is available in CSC Cafe YouTube channel. I will add the link below this video. Coming back from security into performance. So imagine that I have a server and server is getting a lot of load. So what are the options available for me? How to increase throughput when load increases? I can do something like this, or I can do something like this. Okay, we have discussed, right? Scaling up, scaling out, vertical scaling, horizontal scaling. Vertical scaling means you are increasing the capacity of the system. That is one way. And horizontal scaling means you are adding more machines. Vertical scaling means you are increasing the capacity of the machine, but there could be a downtime, right? If you are changing the RAM or configuration of your computer, there will be a downtime, right? But instead, you can increase the number of machines, and all those machines can share load. But does the client have to know the details of these extra machines who are sharing the load? No, right? Somebody has to divide this load between these different servers, right? Who will do that? Load balancer, right? So load balancers routes requests from clients to servers or servers to databases, etc. in a balanced way. So we can have multiple servers at the web server level or at the database layer, and load balancers can be present in any of these levels. Load balancers can be used at software or even hardware level. And we can have multiple layers of load balancers. So imagine that I have only one load balancer and this load balancer is gone. So the whole setup is gone, right? Load balancers can also be load balanced. Load balancer or a set of load balancers can balance load among a set of machines or virtual machines. Okay, now tell me, I have a load balancer and I have 4 servers and I have 4 clients. So how will these 4 client requests get connected to 4 servers? How will I allocate these clients to these servers? The numbers may be different. So I have 8 clients and I have 4 servers. So each server has to take more than one definitely, right? So what are the ways in which I can do? You can use a random algorithm to select one of these 4 in random, or you can use a round robin, or you can use a improved round robin called a weighted round robin, or you can use a path based. What do you mean by path based? In the request URL, in the request path, if you have say images, you go to one server. Say videos, you go to other server. Okay, so whatever is available in the path, you can make use of it and then select a server. Or the final and the most important one for our discussion today, hashing. Okay, basically I can hash the client IP or some parameter from the client, and then I will get a output. Say I get a number. Say I get a number 10. And then I can map that 10 to one of these servers. And before that, so tell me one thing. Which of these load balancing strategy is useful when we have caching on servers? Random, round robin, weighted round robin, path based, or hashing? Okay, there is a question, what if most of the clients got same hash? That is where we'll have to use a good hashing algorithm. There are a lot of good hashing algorithms that are available for us to use. So we don't have to create a hashing algorithm on our own. There are many industry standard ones that we can use. But still, this can happen, and this is called as skewing. Okay, we are not going to look into it now. We are assuming that we have a very decent hashing function for now. So tell me, so out of these, which is better if we have caching? Is it random? Is it round robin? Is it weighted round robin? Is it path based, or is it hashing? Which is better if we have caching on our servers? What do you mean by caching? Caching means client 1 is contacting server 1 now, and server 1 has contacted a database, and server 1 has cached information that is needed for client 1. In round robin, is there any guarantee that the client 1 will next time go to server 1 itself? Yes or no? First request will be sent to server 1, second request will be sent to server 2. So will round robin work here? No, right? Round robin means you don't have any guarantee that C1 or client 1 will always go to server 1. What is that technique that we learned earlier through which a given input will always provide or always create the same output? What is that mechanism? Hashing, right? So when we have caching on servers, hashing based load balancing is the best. With simple hashing mechanism, the hashes based on an input parameter, example IP address, and the number of servers, basically it will convert that IP address into a number, and that number can be mod with the number of servers. For example, imagine you have 4 servers and requests are coming from 10 clients. Assuming we are using hash-based routing that uses some kind of mod function. And for client 5, again, imagine that somehow we got the number 5. So we can do 5 mod 4 and we will get the server number as server 1. What about C6? 6 mod 4 is 2. So we'll use server 2. And what about C7? 7 mod 4 is 3. C8, 8 mod 4. There is a typo. So 8 mod 4 is 0. Maybe we can allocate 0 to S4 here, or we can call a server as S0, anything. But unlike random or round robin, in this particular example, C5 always goes to S1. Another simple question. Can symbol hashing route messages to same server in the event of a server failure? Yes or no? Everybody has to try. Only when you make mistakes, you will learn. 99% is yes. The less than 1% is correct. And how? Imagine you have 4 servers and requests are coming from 10 clients. Okay, assume we are using hash-based routing that uses a mod function. So previous example, C5 mod 4 equal to S1, C6 mod for S2, C7 mod for S3, C8 mod for S4. It is actually a mod 4. There is a typo. So now assume S4 is down. So now we have only 3 servers. C5 mod 3, what it will give? S2. So earlier it was mod 4. Now it is going to be mod 3 because you have only 3 servers. So now C5 will go to S2. Previously C5 was going to S1. What is C6 mod 3? It is S3. Now previously it was S2. And C7 mod 3, it will go to S1. Previously it was going to S3. All allocation has changed, right? Just because one server went down, majority of the clients now started going to different servers. So all those caching is of no use, right? So now again answer, can symbol hashing route messages to same server in the event of a server failure? Yes or no? Okay, now everybody are telling no, right? With the symbol hashing, if the server number change, example, more servers are added or the number of servers are reduced, clients may now go to the new server. So not a problem if servers are stateless, but it is a problem if servers have state or caches. And for this scenario, we can use other forms of hashing itself. And two of the most popular ones are consistent hashing and rendezvous hashing. So I'll talk about consistent hashing now. Initially, we saw that things such as round robin and all will work perfectly. But whenever you have a need for caching and whenever you have need for one particular client going to the same server again and again, then you saw that hashing is a better solution compared to round robin. And then we also saw that the symbol hashing was not just enough. When some server goes wrong or when a new server is added, the number of servers will change. And then whenever you're using a symbol hashing that only uses direct mode operation, most of the clients will now go to a different server because earlier you were moding with mode 4, now it is mode 3, or earlier it was mode 4, then it became mode 5 or mode 6. And then I told you there are two possible solutions, consistent hashing and rendezvous hashing. Okay, consistent hashing. Imagine that I have a circle. So basically a circle means you'll have a lot of numbers, right? You have a lot of numbers in this circle. So I have n points or n numbers here. And what I will do is I will allocate servers in this circle. Basically, I will allocate to some number. Say if it is 1, 2, 3, 4, 5, etc., etc. And then I will allocate a server here, say S1. So this allocation is also through hashing. So I will allocate another server S2 here. I will allocate another S3 here. I'll allocate another S4 here. So whether it is allocated correctly or not depends on the quality of hashing algorithms. And some enhanced algorithms may also allocate it twice. Like S1 may be allocated here as well as here. S3 may be allocated here. For now, forget about these extra ones. Think about only the normal ones because our goal is to understand, right? So now, whenever I have a C1, the hashing function will send this C1 to some part of this circle. It will look for the next available server and it is S1, so it will pick up S1. Imagine that C2 is sent here. So the next available is S2. And C3 is sent here. The next available is S3. And C4 is sent here again. Maybe we have to consider all cases, right? Again, it will also go to S3. And maybe C5 is there. C5 is coming maybe here. So it will go to S4. So basically C1 is going to S1, C2 is going to S2, C3 is going to S3, C4 is going to S3 again, C5 is going to S4. So compared to previous symbol hashing example, which was directly going to a server's number, it is going to any of the numbers between two servers, and then either it will go clockwise or anti-clockwise. It will go in one of these, and then it will find a server. So basically, imagine that this server's number is 10. So if they get a number between 1 and 10, it will go to 10. If it gets from 10 and 20, it will go to 20. And what is the advantage of this approach? So here, whenever you are doing mode operation, imagine that this whole thing is 100 here. The n is 100 here. So the mode operation here is always based on 100, right? The number is not changing. So now what will happen if a server goes down? Imagine that S1 is going down. What will happen? So now C1, previously it was going to S1. Now C1 will go to which one? C1 will go to S2. What about C2? C2 will also go to S2, right? What about C3? C3 will go to S3 again. And C4 will go to S3 again. C5 will go to S4. So here, C1 anyway, it has to go to another server. There is no other way, right? And if there were a few other servers also going to S1, there is no other way, it has to go to other server. But majority of the other ones are now unchanged, right? With symbol hashing, it was not just that client that was affected. Almost all clients were affected because one server went down. So assignment number 10. So today you don't have 10 assignments. So the numbers are calculated from part 1 onwards so that we can refer to it easily. We discussed about consistent hashing. So as an assignment, you can explore about rendezvous hashing or highest random weight hashing, and then try to demonstrate it in any of the programming languages of your choice. So especially people doing programming or people who are in the development track can try to simulate these things in code. It will improve their coding skills, as well as these things will be very thorough. Okay, assignment 11, list down various load balancing strategies that you can find and write 1 to 2 lines about them. And this is a very a good topic to discuss, comparing load balancing with service discovery. You just start searching in Google and you will start to know many things about this. Okay, I'm introducing a lot of terms to you. So you should also start exploring some of these, and maybe we can have discussions in our group again. I also like to learn a lot from you guys. Okay, and assignment number 13, demonstrate round robin and weighted round robin server selection strategies using any programming language of choice. And also explore more on below terms, hardware load balances and software load balances. And also, what do you mean by this DNS round robin? So first of all, what do you mean by DNS, domain name system, right? So whenever a server has a domain name or a load balancer has a domain name, and behind the scenes, you will have a different actual servers with different IP addresses. Okay, so you can explore more, and then we can have more discussions in our study group. Proxies. A proxy is a server application that acts as an intermediary between a client and a server, basically. Normally, we say a proxy for forward proxy. Forward proxy or normal proxy means it acts on behalf of the client. How many of you have tried watching the movies from other countries through VPNs and all? Because even if I have a subscription from US on any platforms, I'll not be able to watch it from India. But many people have overcome it through VPNs, where the server will see that, okay, I'm coming from US only, but actually I'll be coming through a proxy. I will send my request to proxy will send the request to a server. So here, in case of forward proxy, the proxy will be acting on behalf of the client. What is a reverse proxy? Reverse proxy acts on behalf of the server to protect access to the server. So quick question. So can a load balancer be considered as a forward proxy or a reverse proxy? So this is the last question for today. So tell me, load balancer is on whose side? Server side or client side? Load balancer is on whose team? Server's team or client's team? If I am connecting to a website and the website has a load balancer, that load balancer is installed by whom? Client or server? Server, right? Which of these is on the server's team or acts on behalf of server? Reverse proxy, right? So load balancers can be considered as reverse proxy. A reverse proxy commonly performs tasks such as load balancing, authentication, decryption, caching. A lot of things can be done. Basically, it is on server's team, and then it does what server wants it to do. You can demonstrate proxies using any programming language of your choice. You don't have to do it immediately. Start slowly. Try to become experts in systems design maybe in 3 to 6 months time. But if you are really in urgent situation to get a job, maybe you can speed up. But otherwise, take things slowly but consistently. And also list down some real world use cases of proxies that was not discussed here. So these are assignments that are applicable for everybody, not just for developers, right? And then in next part 3B, we will be seeing about replication, sharding, leader election, messaging, polling, streaming, rate limiting, monitoring, etc., etc. So tell me, my usual question to all of you: have you learned anything useful today? Okay, and then this will not be perfect unless you explore more on the assignments, explore more on the terms, and also discuss doubts within the study group. Only then it will be useful, right? Nobody can teach you to be a perfect software architect. You have to learn from experiences and mistakes. As I always tell people, you cannot only learn from your own experiences and your own mistakes. That will never be perfect or complete, at least if you want to go faster. So if as a community, if we can all share our knowledge, if we can all share our experiences, if we can all share our mistakes, then we can all be better software engineers or better software architects. Agree or disagree? Okay, so please be active. If when you do the research, if you find a new term, new example, please share it in the group. If you find some useful link, then you can share it in the group. Okay, we have Azure coaching, and we had AWS coaching. All those coaching programs, especially if I take the Azure coaching program now, they follow a syllabus. They follow a set of materials that has been prepared by Microsoft and given to Microsoft trainers called MCTs, and they follow from that. But to be a good architect, that knowledge is not just enough. That is why we are having all these extracurricular learning and activities. Because I believe that to be an architect, you need to have a lot of knowledge and a lot of experience. You need to have a great breadth of knowledge. And if you can work together, if you can learn together, if you can share things, then we can all become very good software architects now or in future. Okay, so I believe this community will really help all of you in becoming a better you. Okay, thank you all for attending. And if you feel like there is value in attending, then definitely share it in the group and encourage more people to come, help each other, and then we will learn together and master things together. Bye-bye.